This is my problem. I'm on the wrong. All right, hello everybody. I just realized after I went live, I'm on the wrong camera, so give me a second. Right, we are just going to lift the computer up. Hope I don't lose my internet check. There we go. Move that sucker back. Down. There we go. Alright. Move that over there just a little bit. Ta-da! It's not like I do this every day. You would think I would have had it figured out by now, and you would be wrong. Alright, so, hello, welcome, happy day. It is Saturday, April 11th, and we are keeping on around here. There's snow on the ground. It snowed like 2 days in a row, which is fairly unusual after my oldest kid's birthday. But oh well, it's going to melt, I hope, and the daffodils are still coming, so I'm very excited about that. So it is noontime, and it is time for coaching, and is Ben joining us for coaching? I'm doing office hours first. Okay, well, you can sit there, and you can listen in on office hours, and then I'll bring you in when we talk about stuff. So Ben's joining us today because the stuff I actually developed with Ben yesterday. It was pretty interesting. All right, but all of that being said, I want to do coronavirus office hours first. So this is my business page, and for those of you who don't know me, I am a regulatory veterinarian. Okay, I studied comparative medicine when I was in vet school, and I originally trained as a primate veterinarian. And as I'm fond of saying, if there is a more useless skill set in the United States than primate veterinarian, I am unsure what it actually is. So I migrated from the drug side of the house to the food side of the house. And one of the things that I have been doing in coronavirus is not only am I working with physicians, so I'm on a physician page of 25,000 different intensivists. We call them hospitalists, respiratory folks who specialize in respiratory care and things like that, and talking about animal models of coronavirus disease, all right, which I have talked about on office hours, but for those of you who are new, coronaviruses occur in mammalian populations, and when I talk about them, let's just dive into what we are talking about today in office hours. So coronaviruses occur in mammalian populations. So you've heard me say how they occur in cats. They're the underlying cause of a disease called feline infectious peritonitis (FIP). Your kittens are all vaccinated against that. There's coronavirus in dogs. There is coronavirus in cattle. It's the underlying etiology, we call it, of shipping fever in cattle, and we control coronaviridae, in animals through vaccination. But coronaviruses are what we call a single-stranded RNA virus. All right, RNA is a portion of it's a type of genetic coding. It generally encodes for proteins, okay? A single-stranded RNA virus means that the virus itself is one strand of RNA. So y'all have probably heard of DNA, right? Well, DNA is deoxyribose nucleic acid. Deoxy means no oxygen. Ribose is a kind of sugar. And a nucleic acid is an acid that lives in the nucleus of a cell. Well, RNA is ribose nucleic acid, and because it has those oxygens, it hasn't been deoxygenated, it has a different shape. It can have a single strand or a double strand, and coronavirus is a single-stranded RNA virus. RNA encodes for protein, DNA encodes for RNA, which encodes for protein. DNA is vastly more stable. A double helix structure is structurally, that's like what Rosalind Franklin figured out, and what was so brilliant. Joke aside, here's a joke. What did Watson and Crick discover? Rosalind Franklin's notes. So, what Rosalind Franklin figured out is that the helical structure of DNA was really quite stable. Okay, that's why it is the genetic material for life. Now, we have RNA viruses, and what those RNA viruses do is they hijack cellular machinery, and then stop moving my table. They hijack cellular machinery, and they encode for proteins, okay, that then create more of the virus. Right, so that's how single-stranded RNA viruses work. They mutate really fast, all right? This is great during evolution when we need lots of different proteins trying out lots of different things in cells. When it comes to a virus, coronaviruses are very strain-specific. So the strain of coronaviruses that cats get is not the strain of coronaviruses that dogs get, is not the strain that cattle get, is not the strain that chickens get, okay? So that's important to understand. Okay, so the other thing I want to point out is that viruses and pandemics occur across populations. Okay, so this particular coronavirus is the third major coronavirus to come to us since 2000. Okay, and these coronaviruses happen across populations. We think that this particular one either originates or reassorts itself in bats, okay? Because, again, single-stranded RNA virus, it's very unstable and it's easily reassorted. When humans and bats come into contact, then we have problems, and this is where, this is by and large from habitat destruction. So when we see resurgences of Ebola, which we may be having in addition to this, when all Marburg virus, those are all filoviruses, those happen because of increased interaction of humans and bats. So, okay, we do not know why bats are repositories for particularly infectious coronaviruses, but they are, okay? And so we are exploring human-bat interactions, okay, in very well, regulated laboratories, okay? So now, other things to know about coronaviruses. Coronaviruses are enveloped viruses. They have a lipid outer layer. Lipid is another word for fat. Okay? For all of you who are desperate for hand sanitizer, trust me, I get it. Soap and water. Okay? Soap is what we call, is actually a chemical definition. It is the salt of a fatty acid. Okay? And so these fatty acids, what happens is if you have, hang on, all right, you have your coronavirus, all right, and it looks kind of like this, all right, and it's got a corona around it. This part is a lipid, all right, and so if we blow like this section up, this lipid layer looks like this, okay? All right, those are like bonds, those are lipid bonds. All right, or they're bonds that create lipids. Okay, what happens when you have soap? It's the salts of a fatty acid. So you have a fatty acid, right, that looks like this, and it's an acid because it's got an H plus on it. A salt of a fatty acid puts something like sodium on it, all right, and so this then becomes Na+. Well, you know what cellular membranes love? Cellular membranes love themselves some sodium. Sodium is a wicked polar molecule. This is not particularly polar, but what happens is that this goes on here, and you've heard the phrase like dissolves like, right? Well, guess what? The soap comes up on here, and this sodium starts breaking up these bonds, and then all of this starts dissolving all of these bonds. Without this layer, this cannot exist. It just can't. It just dissolves. All right? So, while I totally understand everybody wants hand sanitizer, when you're putting gobs of hand sanitizer on you, what you are actually doing is you're using your hand sanitizer to do this process. It's a super inefficient way to do it. So hand sanitizer goes on clean hands, right? So wash your hands first. Okay, if you have not seen the video, go to the YouTube channel. I'm like up to like 8,000 views of that video. It's like the viral thing I've ever made. Okay, so all right, so that's and so any coronavirus. This is why during cold season, and colds tend to be coronaviruses, we emphasize washing your hands. Okay, so go and watch that video. All right, so that's the coronavirus review. Pop questions in the chat box. If you are on a watch party, I'm not 100% sure if I can see your questions, because I know people watch this through watch parties. But if you like DM me, or this is a public post or whatever, you can come onto the page, or you can come to YouTube and find it. Okay, so the next thing that I want to talk about, because this came up in a discussion today, is comorbidities. One, what are they, and which are the ones we're worried about? Oxygen transfer, and I want to talk about something that's probably going to come up in the news this week that I need everybody to be aware of. All right, and then we're going to talk about a very specific kind of protein, and then we're going to talk immunology 101. All right, because I've got to do a big discussion about this morning, and I figure if a couple of people have questions, everybody has questions, and I want to get that information out to folks so that you can have a solid sense of information. Okay, and then I promise we are going to do today's coaching, which is all about relationships. All right, so let's keep going on this. So comorbidities. All right, morbidity, scary sounding word that it is doctor speak for sickness. All right, so you may have heard of like morbidity and mortality weekly report, MMWR. That's how we keep track of who's sick with what and who died of what. Okay, it's a very, very big report, big journal. Comorbidities are the sicknesses that you have that are part of your daily life. And am I going to go to cytokine storms? Yes, I am going to talk about cytokine storms and what cytokines are and why it matters. Okay, so comorbidities. So when we talk about comorbidities, oftentimes when people have non-infectious diseases, or lifestyle diseases, as we tend to call them, and we are looking at a lot of comorbidities associated with being really, really sick with coronavirus as non-infectious diseases. Okay, so that is diabetes, which unless you have that really rare form, which we think is caused by an infection and happens to like 30-year-old really skinny men, all right, you have diabetes type 1, which is an autoimmune disease, or you have diabetes type 2, which is a disease of your pancreas not being able to support the number of fat cells in your body. Okay, hypertension often follows diabetes, that we're going to get into a little bit over here. Asthma, which is an autoimmune disease of the lungs. Okay, and then a lot of those are associated with hypertension. So hyper means increased, and tension, when we speak of hypertension, most people translate it as high blood pressure. And for most things, translating hypertension as high blood pressure is totally awesome. However, you can be hypertensive in certain areas of your body. So for my Star Trek loving friends out there, we are ugly bags of mostly water, right? Okay, so you can have hypertension, you can have differences in tension that are not supposed to be there, that are elevated from what they are across a cell membrane, all right? So here's one of the things that we are looking at, okay? And this is all, I have to tell you, this is all incredibly, like, novel, and guys, science is the process of getting it wrong and then getting it right. Okay, so be gentle on me. This may change in a week. All right, but here's what happens. All right, so the coronaviruses are respiratory viruses. Oh, and I want to throw something in here on coronavirus review. In animals, coronaviruses are passed through a fecal route, okay, but it's aerosolized fecal matter. So when we're talking about shipping fever control in cattle, we're talking about dust management, but that's dust of manure. right? In concentrated animal feeding operations, right? They kick up a lot of dust, and then they inhale, they like literally inhale manure, okay? So if you think you are a suspect for coronavirus, please be very conscious of toileting habits. If you have questions about that, I'm a returned Peace Corps volunteer, and I'm a doctor, and I promise you poop doesn't bother me, okay? So I just need people to be very conscientious about toileting habits, all right? Because we don't know if the virus is in people is feces, okay? We're going to find out, but I'm not interested in finding out after the fact that we have fecal respiratory transfer because of broken down hospital laundry systems, right? I mean, how good do we really think? I mean, I've worked in, let's put it this way, I have worked in developing facilities associated with pathogen control, so biocontainment facilities for animals, and we're not usually all that worried about air transfer of disease in the laundry, and I can't imagine that that's also not also true in hospitals, so I'm worried about that, I'm not gonna lie. Okay. So that's a little something. So just if you are quarantining at home and you're suspect, just be super careful. Washing your hands, close your toilet lid before you flush because that does aerosolize fecal material if you don't close the toilet lid when you flush. Okay, so again, I promise you, poop doesn't bother me. All right, so anyway, let's get back to oxygen transfer. So here's what when you have coronavirus and it comes in and it lives in your throat, okay, and then it seems like it migrates down your bronchi, your bronchus, and into your bronchial tree and then into the grape-like clusters called alveoli, right, where your oxygen transfer actually happens. And what seems to happen is that the coronavirus hijacks the cellular machinery, okay? And then there is an immune response to it. However, if you have diabetes, if you have asthma, if you have other underlying health conditions, it is entirely possible that your what we call mucosal immunity, so the immunity on the surface of your lungs, is not actually what it needs to be, okay? And so then what happens is the oxygen can't transfer, okay? And when oxygen isn't in the right place, and we have carbon dioxide building up in places where it's not supposed to build up, all of a sudden all sorts of goofy things start to happen with your bloodstream, okay? And when we are looking at some of the drugs that are being pushed with no known, like guys, please stop taking malarial drugs for coronavirus. There's literally no studies that this works. What the hope is that the drugs are working to increase oxygen transfer, because that's what seems to not be happening. There's what we call microthrombi, and to answer Charlie's question, what may be happening, okay, at the cellular level in the lungs is when you have low mucosal immunity, like somebody who has asthma has, okay, and somebody who has asthma is taking, asthma can mean immunocompromised. Yeah, absolutely. Absolutely. It's low mucosal immunity, and then plus taking steroids for asthma. So when we treat asthma, it's a balance of decreasing mucosal immunity and decreasing the immune response in the lungs so that you can breathe. And we generally err on the side of immunity and more oxygen, because without oxygen, immunity doesn't matter, right? So that's why we give steroids. Steroids bind to immune cells and keep them from replicating, because it is the immune cells that make you sick. So these cytokine that we are seeing is the body's over-response in immunity, and it looks like what that's causing is lots and lots of what we call microthrombi. So a thrombus is a blood clot, and a microthrombus is a little teeny tiny blood clot, which are very, very damaging in the lungs, because those alveoli, those great blood clusters where oxygen transfer actually occurs, are so very, very fragile. Okay? And so when you have microthrombi there, your alveoli die. When your alveoli die, you cannot have oxygen transfer. Like those pneumocytes, they're called cells that line your alveoli. We have type 1, type 2, and I think type 3. And pneumocytes, when they die, oxygen transfer doesn't happen. Okay? And it is likely we are seeing that what is killing people is a failure of oxygen transfer because of cellular damage. When we put them on ventilators, this might actually make it worse, which is why I've seen putting people in prone positions makes it better because it changes the pressure enough, all right, and doesn't work against what the body is doing. Now that is more than conjecture and not quite a hypothesis. Okay, this is just from what I am reading. So when we have diabetes or we have underlying associated with blockage of the arteries, when your arteries block, it means you're some kind of white blood cells like clogging up your arteries. It means your immune system is working right, okay, and that seems to be very, very related to getting extra sick coronavirus and your body going overboard and trying to trying to kill the virus. All right, so that is oxygen transfer. Okay, now ACE2. ACE stands for angiotensin converting enzyme number 2. All right, you may have heard of angiotensin converting enzyme if you are on a ACE inhibitor. Okay, those are aimed at angiotensin converting enzyme 1. We're talking about number 2. All right, and what it seems, this was published in the Lancet last week, 10 days ago. It looks like one of the things that we are seeing is upregulation of ACE2, and that is causing all sorts of things to go wrong in the lungs, right? And some of the drugs that we are giving, okay, and some of the conditions like diabetes, when you give antihypertensives, we bring down ACE1, but we commensurately increase ACE2, and that seems to be working against how we want the lungs to respond. Okay, so ACE2 upregulates, and upregulation of ACE2 seems to be correlated with poor outcomes. All right, it's not 100% clear on that, and yes, the pneumocytes do grow back. It's not 100% clear what the correlation is, but people with comorbidities, other sicknesses, tend to be a lot better at upregulating ACE2. Okay, and then that goes in and that creates more of an issue around oxygen transfer. So one of the things that I saw today, which I want to put my tinfoil hat on as a veterinarian, is people treating these we call these oxygen dyscrasias, treating oxygen dyscrasias with a drug called methylene blue. Methylene blue we use in fish medicine, okay, and if your fish is sick for it, just about anything, drop some methylene blue in there and it'll probably cure it because it's a fish and they have really weird immune systems. All right. My guess is after we stop talking about malarial drugs, we're going to start talking about methylene blue. Please do not go out and start buying methylene blue and treating yourself with methylene blue because it will cause methemoglobinemia, which is the same thing as carbon monoxide poisoning. Okay, and I saw that a couple of times on the internet just this morning, and I'm like trying not to freak out about it, and I'm telling my veterinary friends about it. People start asking about methylene blue. All right, so this is guys, if methylene blue doesn't work in fish, then we try formaldehyde. I don't recommend either for the treatment of coronavirus. So this gets us to Immunology 101. All right, so I got a question both from my kids and on the internet today about about basic immunology and why all of this stuff is important and why this stuff is happening. Okay, we have two kinds of immunity. We have innate or humoral, coming from like the Western concept of humors. Um, we have innate or humoral immunity, and then we have adaptive immunity. So innate immunity is based on white blood cells that you already have circulating in your blood system. Okay, your white blood cells are produced by your bone marrow. They are sometimes constructed in your spleen, depending on what your bone marrow is doing. All right, and they are in charge of finding pathogens, viruses and bacteria and parasites, attacking them and bringing in like they are the cavalry. Okay, so if we look at a cell and we look at innate immunity in a cell, right? So this is our virus. I'll do this in blue. How about? Okay, so we have a cell, right? We have a cell, all right? Pretend this is a type 2 pneumocyte that lines alveolus. Okay, the cell's got a nucleus right there, all right? And the coronavirus, which I'll make in green again, the coronavirus comes in, right? And it's much, much smaller than the cell. And starts attacking this cell. I don't know if you can see that little teeny dot, but it's a little teeny dot. All right. So what happens is that circulating in the body, all right, and this pneumocyte here has near it other kinds of cells. This big old nucleus, and this is called a macrophage. Right? Macro, big, phage, eating. What this thing does is it goes in and it's like a little Pac-Man, and it chomps up, right? It chomps up this virus, but in the process, it like destroys this cell, and this cell is like no more. So you can kind of see what happens, right? That if you lose too many of these cells in your lungs, it's bad. So this is your immunity. These macrophages have coding for them to recognize a significant number of pathogens we as humans have had in us for literally millennia. Okay? And it is our first line of defense against pathogens. So you get a strep bacteria, you get parasites. Macrophages will also go against parasites, and they do their level best. But this releases all sorts of things. Okay, and so we were talking about cytokine storm. As this cell dies, it releases something called tumor necrosis factor. So named because we were studying cancer when we found it, and tumor necrosis factor makes tumors die. If only it were that easy to kill cancer. But tumor necrosis factor and their alpha, beta, gamma, delta, all that sort of stuff, calls out for this is a cytokine, calls out for the troops to come in, all right? And so then we get more troops, all right? So this is write that in black here. Oh. So this is innate over here. And we get the innate response first, right? And then the innate response kicks off the adaptive response. All right, the innate response kicks off the adaptive response. Is everybody glad I paid attention in immunology? Okay, so then the adaptive response comes in here with different kinds of beta cells and T cells. Okay. These beta cells and T cells create things called immunoglobulins that essentially, this is like way magnified, okay? So this is like way magnified. These immunoglobulins, you guys have heard about immunoglobulin tests? This is what we're testing, okay? Immunoglobulins. There's immunoglobulins A, B, gamma, delta. I mean, like, we got like immunoglobulins coming out our ears, right? And our immunoglobulins have all different structures, and I'm not doing that. But what our immunoglobulins have at the end is something called the hypervariable region. This immunoglobulin comes in on these little viruses here, all right, as they are circulating, because of course this also happens across populations of blood cells. So things that happen across populations of people, I want you to narrow that the heck down into your own body, and these things happen across populations of blood cells, okay? So these immunoglobulins come in here and look at this virus, and this hypervariable region comes in here, all right? And you have a hypervariable region, and this hypervariable region attaches to this virus, okay? And then once this immunoglobulin has the right kind of coding, it kicks back into the adaptive immune system and goes to the adaptive immune system and says, hey, Mr. T cell, please make me more of things that look like this. Because things that look like this kill things that look like this. All right, and that is adaptive immunity. So, of course, if you have an underlying immunosuppression that attacks T cells, which we know as human immunodeficiency virus, you have a problem. And this is why people with human immunodeficiency viruses are immunodeficient. It's because their adaptive immunity doesn't work, okay? Because they have a virus that attacks these cells, their T counts plummet, right? And so that's why we measure T cell counts in HIV patients, is because we've got the virus under control if they have circulating T cells. All right, and so when you have these immunoglobulins and they attach, the more we can, the more kinds of immunoglobulins attach and go back to the blood cells, right, to these T and B cells, and more of these, the more adaptive immunity can come in and kill the virus without killing the cells. Okay, so this is why we're going after a test that tests for antibodies. This is an antibody. This is an antigen, okay, and together they form an antigen-antibody complex. All right, and that my suspicion is that also causes further disease down the line. That's a type 3 reaction, right? And so when we are looking at doing plasmapheresis and donating plasma, and when we were in the Ebola outbreak and we were trying to protect first responders, what we did was we went and got blood from people and took these bits out, right? And we gave it to responders, because if they get this, then their own body's immune system can go in and can create the immune response that they need, okay, to protect them from the virus while we are working on creating a vaccine. So vaccines then are designed, we create vaccines to take very small bits of this cell, of this virus membrane, this lipid membrane, whatever we can figure out, all right? We get what we can so that we can stimulate this sort of response. But this response takes time. It is adaptive immunity. Your innate immunity is immediate, but we all know when vaccine, it is not immediate. So, okay, these things take time, all right? So not only do we have to engineer the vaccine, we have to do clinical trials and make sure it works, okay, and doesn't create other sicknesses. Those of us who have been in the Army, we know that you can get, we had an anthrax vaccine that a lot of people got in Gulf War I and then the beginning of Gulf War II that made people fairly sick, right? Because you're in the Army. Okay, so this stuff is really quite complicated. It is a generate vaccine. It will take a while, right? So that's why I say it's going to be like till we have widespread vaccination for this. And Charlie says immunoglobulins equals antibody. Yes, all right. And so when we do an antibody test, this is the last thing I'll cover, and then I'm going to talk about relationships here. When we are looking at a immunoglobulin test, it is a test of immunohistochemistry. All right. I'll explain what all that means. Histochemistry. Okay, so we do this kind of testing all the time. All the time, okay? Immunohistochemistry is one kind of test, all right? It is often compared to PCR, which is polymerase chain reaction. Polymerase chain reaction tests for DNA or RNA, okay? Immunohistochemistry tests for proteins, all right? Proteomics is immunohistochemistry. So the test, I think it's an Abbott Laboratories test, what they are looking for is they take your blood, okay, and they have antibodies to the antibodies, if that makes sense, all right? So we're going to take another color. It's a good thing we have colored Sharpies around here. All right, so we take that antibody that we had over here. So I'm going to redraw this antibody, okay? So that antibody, which now is in this hypervariable region, encoded right here, it's encoded for coronavirus, okay? It's encoded for coronavirus, all right? You take blood, and the blood drop has these antibodies in it. Then what the test does is it comes in with a match for this, a little better, all right? That is its own antibodies, okay? So this is this red thing is anti this, all right? This we colorize, okay? Also how pregnancy tests work. We colorize this, and this thing has a big old blob on the end that is a color, right? So, right? And then what you do is you filter it. You take this and you put the plasma in a well, right? So you put the blood drop in a well back here, right? Do the whole thing. Okay, so you put the blood drop in the well right here, okay? Then the antibodies migrate across the plate, all right? And this plate is populated with these guys, right? So this dude comes in here and he says, oh, I match up with that, right? And then you have an antigen-antibody complex. And there are other liquids and things in here, and then this migrates and gets caught on your lines, okay? So if it makes it, well, you guys can't see that, sorry. All right, and so if it makes it, right, on the whole test, so this is a blow up of your test, 2 lines, this sucker is going to make it all the way over here, all right, and it's going to get caught on that line and cause another reaction, okay? So this thing, this red thing is going to cause another reaction over here, and these guys are all going to line up right here, and you're going to have a positive antibody test, okay? That's the science, right? So let me move that back. All right, so that is, that's the science behind it. So there you go. I tried, right? Not an artist, but I did my best. So that's coronavirus office hours. If you guys found this helpful, I will do it again next Saturday. Keep up your questions. So with that, I want to pivot, all right, and talk about what we've been talking about over the course of the whole week, which is talking about relationships. And when talking about relationships and telling ourselves the truth of our relationships. So, all right, this one is probably the most simple, but the hardest to do, right? Because here's the deal. Y'all have seen me. Honey, can you give me another post-it pad over there? So y'all have seen me draw this stuff up, okay? That No, the big ones. The big yellow ones that are moving up there. Hot, hot. Put right hand down. Right, your other right, dude. Turn right. That big notepad right there. Yay, Ben. There we go. No, doing fine. Can somebody make sure the vegetables are not burning? Daddy in charge of that, please? Thanks. Okay, so we've been talking about relationships, okay? And we've been, there we go. Yes, Ben's going to come and help us with this because we did a lot of this when we were doing our own self-coaching the other day. All right, and so the truth is that when we talk about telling ourselves about relationships, I don't know if you remember, but I drew out some side there. Okay, so we have relationships, all right, and this is the sum total of your relationships, and your relationship, your best relationships, but you have also your relationships with other people. So you have relationships with self and relationships with other people. Okay? When we start talking about developing the capabilities to understand our own self and to have the that we want, okay, it starts by telling ourselves the truth. This is probably some of the hardest we have to, okay? And what makes it really hard is that if you dive into Buddhism, okay, and you look at these sorts of things, there is no self. And what happens is when you take yourself out of, by stepping out of understanding that your thoughts are not you, right? Your thoughts are not you. Your feelings are not you. Okay? This concept of self actually works. And so when we use the truth of ourselves, okay, it automatically takes us, it can do one of two things, okay? You can either dissolve the concept of self, which in Buddhism allows us to attain enlightenment, as I gather, okay, not a buzz. Or you can use it as a belief to beat the snot out of yourself about how yourself can be better. I will tell you, feeling neutral about yourself better than beating the snot out of yourself, all right? And then your relationships, when I talk about tell the truth of your relationships, it's awfully easy to say my truth about my relationships. This is one of the things we've been working on in the house, is often what we see as the truth of our relationships is how we feel like other people are supposed to act so that we feel better.
As I stressed in another episode, I don't remember which, always tell the truth.
Always tell the truth.
I have stressed that so much.
Right. So Ben and I, yesterday night, figured out... Pardon me? 11 blocks down. Yeah, okay, right. So we figured out how to graph this, okay, because I'm all about the math. All right, and so we came up with a really cool way to graph how much you are invested in being neutral about things versus being in really high emotional intensity. Because here's the thing, when you have really high emotional intensity about things, you are tending to believe your own story. Now, sometimes that's fine because you feel good about things. Sometimes it's not, all right? And so, I want to draw this out. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I'll just do this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, my friends. You know I love you. All right. Alright, so over here on the y-axis, this is emotional intensity, and this is time.
EP, extraterrestrial.
Emotional intensity, that's EI. Alright? 0, 0. This is, provided you don't have nightmares, right before you wake up. Okay? So your emotional intensity, right before you wake up, you are asleep, are asleep.
I think this is it. Yesterday.
Can we do yesterday's? Yeah, sure. Okay, yeah, we can do yesterday's. All right, and so what Ben and I figured out, and I'm going to let Ben do this. Hang on, let me explain the axis. So this axis is emotional intensity, okay? And for us, we call it dialing up to 11. That's why I had 11 blocks.
11, where I am threatening to hurt myself and occasionally going to the ER.
Right, exactly. And
I
then
have that
time, and this is time over the day.
Like, it's 12:45 right now, like
Right.
time to 7, 8, 9, 4, 8, 9, 9, 9.
They get it. They get it. Okay. So, Ben, let's start with yesterday. So, where did you wake up yesterday?
I don't think it's
We decided that you woke up at about a 1. Okay, so we
Okay.
woke up and we came in and we snuggled with Mama, right?
I stayed there for about a few hours.
Right? And so we were there and we were about a 1. Okay?
And then I got my schoolwork done.
Okay, then we planned our schoolwork.
Oh yeah, we planned it while
Right?
sleeping in bed.
We planned our schoolwork, and that was actually pretty interesting. And this goes to show you how much the planning process is really super helpful. We planned our schoolwork,
I did ramp up a bit in there.
and you ramped up a bit, but not much. And you did all of your schoolwork like at about a 1.5, which wasn't, guys, this is amazing. Okay, for any of our kids that are homeschooling right now, for them to get their homework done, like their schoolwork done at a like 1.5 on the emotional intensity scale, truly amazing.
So I was doing my schoolwork at around 9. I had a call with my teacher, Mr. Goldman. And one of my friends was supposed to be there, and he didn't. So I ramped up, like, doing this.
Right, so you ramped up. There you go. So you ramped up.
Ramped up. Not to stay.
Right. So you ramped up to here when your friend didn't show up.
Yes.
Right. And so if 1 is we're doing pretty good,
Yeah. Just do it.
right, and
And
we're
that's
just 3. You got to about a 3. And at about a 3, we start looking at aggressive silliness. Okay.
But let me just point this out. I wasn't very aggressively silly. I was sad and came downstairs and talked to my mom.
Right? So you were sad, and you came downstairs and you talked to Mama, right? And you came back down to about a 2, right? Okay, so feeling good, and then in there is giving permission to feel our feelings, right?
Now, this is for a previous day, but so one day I woke up at like a 3, and I just went really up.
Right.
And at about a 10, me and my dad sort of can get a little mad at each other. At 10, we have something called jumping into the pool.
Hang on, we're gonna get there. Just hold on to the drama. I know you wanna talk about it. Okay, so Ben managed to come back down to a 2, right? He came back down to a 2. Alright, and then we kind of went like this, alright, and you were like feeling all of your feelings, and then you actually did get to talk with your friend, right?
Which I'm gonna do.
Right? And then he was like that. But then evening comes along, right? Evening comes along, and we ramp up to aggressive silliness a little bit. Alright, and we tend to go from aggressive silliness to actual aggression, right?
And I can explain why. You want me to?
And did you guys actually get aggressive with each other?
Yes.
Yes. Okay, so then we were here and ramped up, right? And then we get actually aggressive with each other. But then we started reading, right? We all calm down.
But me and my brother, I was making cookies, and I found out that my brother had been snitching
Right.
cookie dough. Which, if the kidneys,
Right.
my mom's business
Hemolytic
would
uremic
never
syndrome.
recover.
Very bad.
My mom's
right?
business would never recover.
So what happened is that's right. So we had a point right here that saving for today.
And now we're the only people gonna be having
Right?
it. My brother's happy.
So his emotional intensity really, really ramped up, okay? And then it kind of came down, but if we continued this graph for today, I will tell you that then we decided to go up in a 3. But this is the part where I want to point out. We're telling ourselves the truth about our relationships. Okay? Right here, we figured out how to graph when we are what we call in life coaching. When we are what we call it in life coaching is diving into the pool. Okay? Right here, as the emotional intensity is up and up and up and up and up, Ben is believing more of his own story about how his brother should be acting. Okay? And we call that being in the pool. Okay? Because we have, like Ben has a story about what Zach should be doing. Okay? But Zach is his own independent human being. Okay? And people gonna people, and 12-year-olds are people, right?
Yes.
But Ben is also a people. But what ends up happening to increase the level of emotional intensity, and what I want you to take a look at when you're looking at emotional intensity is in an emotionally charged situation. This is how you can tell yourself the truth. In an emotionally charged situation, do you tend to escalate the emotional energy or de-escalate the emotional energy?
I generally tend to escalate it.
Ben tends to escalate it because Ben is 10. Okay? And we have to, these are learned and learnable skills on how to de-escalate emotional energy.
So, in order to continue like this, we go down here,
Yeah.
and then this is where we discovered how to do this graph.
And then, we were back at a 1.
Yeah.
But we discovered how to do this graph when we were all good and we were out of emotional intensity, right? And we call this being in the pool because I want you to think about...
It looks like a pool.
Because it looks like a pool, right? Yeah. What are you doing? Jump right on in, okay? And none of the water can escape until you decide to let your emotional intensity come down. And that all of this all comes from your thoughts, right? So all of that comes, yes, jumping in with emotional intensity, right? So you can graph this over the course of your day, right? What is, right? Just carry, again, brand Dirigo Food Safety, or actually go get one of those little notebooks. Go get our little white notebooks. We have little white notebooks, and if you want a little white notebook, just send me again, and we'll put them in the send it to you, okay? For you to write down all the way to 11, right?
Trust me, because 11 is... Sorry.
Right, so we have these lovely little Dirigo Food Safety notebooks. If you want one, send me a DM with your okay? And you can do this, I promise, to just know your level of emotional intensity. Okay? So this is one of the things that you can do about you can pick one thing, you can pick over the course of a day, pick any kind of time frame. Start graphing your emotional intensity, and that is telling you the truth about your relationship with yourself and your relationship with other people, because you can write down the circumstances around it.
I just want to point this out that one of the reasons I ran down is because me and my dad, and if you have any pipe cleaners, this would help. So me and my dad and my sister had a conversation about how we see our escalation and how we want to see it. I want to see mine is straight. That's how it is. Sorry.
It just goes straight up. Sometimes.
Like, this is mostly straight.
Right.
It's more straight than it is not.
Right.
But how I want to see it is a stairway. So that way, I'm there for like, I don't know, 2 minutes. I'm able to catch it before I dial up one more time. And then I'm going to catch it again. And at that point, I am like going.
Then at that point, you're unsafe. But what was really good is when Ben recognized he was escalating, he was able to use a thing. Okay, so you know how we do the 5, 4, 3, 2, 1 exercise? I do it with Ben all the time. But using using a pipe cleaner like they did, okay, allows the kids to touch something and grab something, right? So that they can concentrate. It takes them, if you think about it, you cannot be graphing your emotional intensity and be emotionally intense at the same time. It's like literally not possible.
Well, you can use like add one, but that's not very intense.
But that's not very intense, right? And so, and colors, and we could talk about the colors, and it's a way of getting out of your own brain. Okay, so I have talked about on this before. I talk about the dogs of my inner child. We have a
right
yappy little poodle.
There's one right there.
Yes, I know. That's the German Shepherd. So I have a yappy little poodle, and then I have, and that's energy. And then I have a very, very loud terrier who's like barking, trying to get somebody to pay attention to them. And then I have the German Shepherd, okay? And so our German Shepherd is right over there. Stop jumping. And the German Shepherd is the very calm, focused energy because that's what German Shepherds most of the time are, at least mine. And there's not a whole lot of things, not a whole lot of goofy German Shepherds out there. And when you allow yourself to come back into your body by using something like pipe cleaners, by graphing or whatever, it allows all of those dogs to like calm the heck down.
Now, can you do the one for Thursday?
I think that's probably enough. I think that's probably enough. We've been on now for close to an hour, and so Ben and I are going to sign off. And your work, should you choose to do it, is to start with this graph, right, and tell yourself the truth about your relationships and measure your emotional intensity, because your mind management is the number one asset in your life. Okay. I promise you. All right, so then tomorrow we are going to dive into week 2, and we're going to start talking about developing our capabilities to have what we have and how our feelings got us what we have. All right, you are all amazing, beautiful people. If you want a notebook, send us your address, and we will send you notebooks. You are, and we will see you. Bye, guys.
Bye.